It's one of the last few assessment statements in our first unit of systems, and it's to define the nature of equilibrium. So to start with that, we're going to start off what the heck is an equilibrium. And so what that is the tendency of a system to return to an original state following a disturbance. There are two kinds of states or equilibriums that systems can be in. So there's a steady state equilibrium, and this is going to be found in open systems. So what this means is that open systems, it exchanges matter and energy with its surroundings. So with continuous inputs and outputs, of that energy and matter, the system as a whole remains in more or less a constant state. So if we were to put this in a graph, and I'll make there's not very good lines, I'm sorry, but if system state is our y, and time is our x, we can think of a system changing over time. So let's think of a person and their kind of average body weight. Right? So most of us on a day-to-day basis, we eat food, inputs, and of course we have our own outputs. But over time, maybe things like Thanksgiving may come by. All right, so we kind of put on a little more weight than we'd like to, and then we come back down after getting back into exercise and such things like that. So we have inputs and outputs on a regular basis. We go up and down in our body weight. But if we were to look at the average body weight for the person, we're going to have an average state. So my red line is average state. So that's one kind of equilibrium we could have. And then of course there's a static equilibrium, and this is no change over time. So for our graph for this example, we have our system state, we have time over here, and what this means is nothing's going to change. There's no fluctuations, just nothing changes. You can imagine this would be very hard for a living system to maintain, so this is going to be non-living. So if I put a pile of books on my desk and I never clean and I never take care of it, that's never going to change. Rocks, for instance, over a reservable amount of time, those rocks and mountains are not going to change. So when we're looking at our we're looking at our static system and our steady state equilibrium, you have to think about whether or not they're stable or unstable. I'll use blue for this. So a stable system right, it tends to return to the same equilibrium state. this is, of course, after disturbance. And a visual I think that works really well is if you think of a ramp like this. All right, if I were to put a ball in this ramp, it's going to go back and forth. There's going to be a disturbance, but at the very, very end, eventually this ball is going to end up at the same place every time I disturb it, which is going to be at the bottom here. All right. So like I said, no matter what the disturbance is, eventually it's going to end up back here. Then we have an unstable. Equilibrium or system. So that means after disturbance, the system will return to a new equilibrium. So we kind of take our ramp from above and just flip it over. And let's pretend we have our ball and it's at the top. It's in this equilibrium up here, right? But if I move it, if I disturb it, it's never going to end up back up here. Okay, so that's kind of the reasoning between an unstable state. A lot of people think that what's happening with global warming is that we're in an unstable we disturbed kind of the temperature of the earth and it's unstable. We'll never be able to get back to where we are. And that has to do a lot with feedback loops, which we'll talk about in class. So in class, when you come on Monday, what I need you guys to think about is we've talked about systems, and I want you guys to design a fish tank. So what are the things you need to have a steady and stable equilibrium in our fish tank? Ooh, spelled that wrong, guys. Stable / steady. And hopefully, if you guys figure this out correctly in class, we'll be able to make our fish tanks and they'll be able to be in a closed system and last the whole school year. So really think about that and really be prepared to talk about this as kind of our lab / projects for our systems unit.